Have you ever gazed up at the night sky and wondered what secrets lie hidden in the shimmering light of the planets? Saturn, the jewel of our solar system, has captivated us for centuries with its stunning rings and golden glow. For a long time, we could only guess what it was truly like. We built stories and myths, imagining solid rings you could walk on and a quiet, unchanging planet. But science tells a different, more exciting story. This is a tale of myth versus reality, long-held beliefs challenged by incredible discoveries, all thanks to a brave little spacecraft called Cassini. Our guide on this journey is the Cassini spacecraft. It was sent on a grand tour to uncover truths behind Saturn's face. For a very long time, people looked at Saturn through telescopes and saw a solid, continuous band of light. It was easy to imagine the rings as a single, solid highway circling the planet, a smooth, icy racetrack in space. This was our first and most popular myth, that Saturn's rings were solid structures. You could, in theory, land a spaceship on them and take a walk. It was a beautiful idea, but the reality that Cassini showed us is far more delicate and chaotic. The rings are not solid at all. Instead, they are made of countless individual particles of ice and rock, tiny dust grains, smaller than a speck of sand, enormous chunks as big as a house, all orbiting together, like a blizzard frozen in time. Cassini flew closer than any spacecraft before, confirming the rings are almost entirely water ice, which is why they shine so brightly in the sunlight. It's like a vast, flat river of glittering ice crystals, all moving in a cosmic dance, held by Saturn's immense gravity. Cassini revealed the rings are not a quiet, static system. They are alive with activity. Tiny shepherd moons orbit within and alongside the rings, using their gravity to carve out gaps and keep the ring edges sharp. The rings also have waves, ripples, driven by the gravitational pull of Saturn's larger moons. It's a surprisingly dynamic environment, more like a bustling city of ice than a silent, solid road. But here is where the mystery deepens. Cassini measured the mass of the rings and found less than many expected. Constant meteoroid dust should darken the rings over time. Their brightness suggests they might be young, perhaps only 100 million years old. In cosmic terms, that's recent. Dinosaurs still roamed Earth when they may have formed. Before Cassini arrived at Saturn, Enceladus was just another small, icy dot in the sky. A cold, dead world, frozen solid. But Cassini turned this idea on its head during daring flybys. It saw giant plumes of water vapor and ice erupting from the South Pole, shooting hundreds of kilometers into space. This tiny moon was geologically active. Cassini flew directly through the plumes to sample what was inside. Its instruments tasted water, salt, silica, like the sand on Earth, and complex organic molecules. Salt points to a large liquid ocean beneath the ice. Silica hints at hydrothermal vents on the ocean floor, a tantalizing recipe for life, without sunlight. Enceladus became a prime place to search for life. However, Cassini's instruments had their limits. They could detect ingredients for life, not life itself. The ocean is there, salty and warm at the floor, but we could not see into that ocean. We don't know how deep it is, how big the hydrothermal vents are, or what complex chemistry unfolds in the dark. Is there simple microbial life thriving there, or just a sterile chemical soup? Answering this is beyond Cassini, and a top priority for future missions. Another world would upend our expectations even more: Titan. A thick atmosphere and weather, yet profoundly different from Earth. Cassini showed us Titan, similar to Earth in some ways, yet alien. It has a thick atmosphere, even denser than Earth's. It has weather, it has clouds, it has rain, it has rivers, it has lakes and seas. The twist: everything runs on methane and ethane, not water. At 179 degrees C, water is hard as rock. Liquid hydrocarbons carve channels and pool near the poles. Cassini's radar mapped Titan for the first time, revealing shorelines, islands, and deltas, familiar shapes sculpted by a methane cycle like Earth's water cycle. A moment of pure discovery for the Cassini team. Despite breakthroughs, Titan keeps its biggest secrets. Huygens landed and showed a riverbed strewn with ice pebbles. We still don't know what happens in the depths of its seas. Could non-water-based life swim there? Beneath the crust likely lies a vast liquid water ocean. We have no idea what it's like, or if it supports life. Titan is a world of two oceans, both mysterious. To grasp these discoveries, understand Cassini itself. Not just a camera, but a lab with 12 instruments. It orbited for years to watch seasons and change. Gravity assists flung it outward on its grand tour. From afar, Saturn looks calm, but Cassini revealed some of the most violent weather. Winds near the equator exceed 1/1600 kilometers per hour, far faster than any hurricane on Earth. The most spectacular events, great white spots, colossal storms that could swallow Earth. They appear roughly once every 30 years. In 2010, one began as a small, bright spot, then wrapped around the planet within months. A storm that literally ate its own tail. Cassini measured temperatures, chemistry, and lightning 10,000 times stronger than Earth's. Likely powered by deep convection, yet the true trigger remains unknown. We once imagined planets as perfect solid spheres. Gas giants like Saturn are not solid at all, and the classic core plus metallic hydrogen model seemed tidy. Cassini's close passes mapped Saturn's gravity with precision. Results suggest no well-defined solid core, but a diffuse, slushy core extending to about 60% of the radius. This reshapes how we think gas giants form and evolve. It also raises new questions about Saturn's magnetic field. Gravity data gives hints. We cannot see the core directly. Is it stable or still evolving? How does this fuzzy heart influence the weather above? Planets with magnetic fields have magnetospheres, shields that deflect the solar wind. On Earth, this gives us auroras, northern and southern lights. Saturn's magnetosphere is one of the strangest. Earth's magnetic axis is tilted about 11 degrees, but Cassini found Saturn's field is almost perfectly aligned. The tilt is under 0.007 degrees, nearly straight. That's puzzling. Dynamo theory needs a tilt. Maybe another mechanism works in or near the fuzzy core. Cassini also saw the moons, especially Enceladus, shape a plasma-rich environment. Even Saturn's day length stays elusive. The invisible forces remain not fully understood. Cassini's final plunge marked the end of an era. For 13 years, it was our eyes and ears in a distant system, turning a faint dot into a living, breathing world. It busted centuries-old myths. The rings are a dynamic blizzard of ice, not a solid highway. The moons are active places of possibility. Cassini left us its greatest legacy, questions. We know Enceladus has a salty ocean. Do we dare test it for life? We've mapped Titan's seas. Can we explore them? What powers Saturn's giant storms from below? How does a perfect aligned magnetic field persist? New missions are already being dreamed up. The secrets of Saturn wait in the cold and the dark, and one day we will go back.